This presentation is going to review the differences between work and power. As you can read on the screen, work is the transfer of energy that occurs when a force makes an object move. You can think how this is a different definition than our everyday use of the word work. Maybe the folks at home say that they're going to work and that's where they make their money. Well, work in a scientific sense is focused on the amount of force you place on an object and how much distance is changed because of that force. So to make it simple, work is done on an object when a force is exerted on the object and it moves in the direction of the force. So let's clarify that. The girl in the picture is doing work. She's lifting the books from the floor. She applies a force to the books to lift them up, and the books then move in that direction a certain distance. Note that the distance is up, and so is the force. So that is a good demonstration of work being done. The picture that's now on the right side of the screen is the same girl, but she's no longer doing work on the books. This might seem weird because she seems to be still doing something with the books, but notice that the force that she's applying to the books is up. And the distance that she's traveling is going from left to right. So work is not being done in this example. Remember that the key part here is that we should be adding energy to the object when we're doing work on it. So we're looking at the situation with the girl on the left. She's actually increasing the gravitational potential energy of those books. Thus, the books now have more energy. That is the definition of doing work. Always remember that when work is done, a transfer of energy is always occurring. In a later video, we'll explore in more detail how to calculate work, but there is a way. If we know the force and the distance, by multiplying those together, we end up with a unit called joule, which we've already know from looking at energy. Power is a rate. When we think about work, it's essentially how much work can something be done to an object over a certain amount of time. So the official definition for power is the amount of work done in 1 second. Now, horsepower is a common, although non-metric unit of measuring power. Now, if you remember your history, James Watt, who invented the steam engine, came up with the idea of using the horse and relate it to the power of his steam engine. So what we are measuring power in science, we're using a unit called a watt. Now, we know of horsepower. Notice my somewhat humorous picture here. Horsepower is equal to, so if you talk about the horsepower of a car or of a train or something, you can actually convert it into watts. And 1 horsepower is equal to 746 watts, because that's the unit that we're measuring energy. And it's really energy per second, right? Because that's the amount of work done per second. So it's actually going to be energy per second. In a future video, you can look more into how to calculate power if you know the amount of work and the amount of time it takes to do work onto an object. When we think of power, we usually think of electric power. And when we think of watts, we definitely think about electric power because we look at wattage of light bulbs to understand how bright the bulb is going to be. So if you're going out shopping for a new light bulb, you want to know how bright is that bulb going to be. You know, if you're in maybe a bedroom, you want to have a softer light, you want a lower wattage. And if you have a big room that needs to be filled with light, say a living room, then you need to have a brighter bulb, which requires a higher wattage. So we will also explore this in more detail in another video. To review quickly, here are the big ideas from this particular video. Work is force applied over some distance and is measured in joules, which gets the capital J as a unit. Power is the rate at which work is done, and the unit that we use there is known as a watt.